Hey everyone, this is Tia Yusuf, and in this video, we're going to cover Thevenin equivalent circuits in just 2 minutes. The Thevenin equivalent theorem states that I can take any linear circuit and then simplify it to a voltage source in series with a resistor. We have to find what the Thevenin and Thevenin values are. Let's start by finding Thevenin. Thevenin is finding the equivalent voltage drop of a modified circuit. In this modified circuit, we remove the load, we open it, and mark those terminals A and B. Our next step is to draw current arrows and find what can be equivalent to VAB. I've now drawn my current arrows. My current goes through every component that is closed at two ends. The 2.4 kilo ohms is connected at both ends, meaning it's in a closed loop. Same with the 1.2. There's current going through both of these resistors. The R3, the 3.3 kilo ohm resistor, is not closed at both ends. It's not connected because remember, this A is an open circuit. That means that there's no current going through the 3.3 kilo ohm resistor and there's no voltage drop. I can represent this by marking now all of my A terminal, the wire connecting these three components. And that is because there's no voltage drop across here. It's one node of all the same voltage. Same with node B. I have this orange highlighting all this wire of all the ground voltage. So this means that my Thevenin is equal to my 1.2 kilo ohm resistor, or even the voltage of my 2.4 kilo ohm resistor, or the current source. I decided to solve for the voltage of the 1.2 kilo ohm resistor. All calculations will get you the same value. I did current divider to find the current going through this resistor, and then I did Ohm's law to find that I have 115.2 volts as my Thevenin. That means A is 115 volts greater than B. Our next step is to find Thevenin. Thevenin can be found by first modifying our circuit. We want to deactivate our current sources and our voltage sources. Deactivating a current source means we want to create it to be an open circuit. That means we're now supplying 0 amps into our circuit. For voltage sources, we want to transform them into a short wire, meaning we're supplying 0 volts. I have now removed my current source and replaced it with an open circuit. I will now look at my current arrows. It will go through the 3.3, the 1.2, and the 2.4 kilo ohm resistor. This is because my 2.4 kilo ohm resistor is connected at both ends to the rest of my circuit. Same with the 1.2. That means there's a closed loop for current to flow, and I can take these resistors into account for finding my Thevenin resistance. I found the resistance of those two resistors combined in parallel and then added to the 3.3 kilo ohm in series. The final step is to redraw the equivalent circuit based on the problem requirements. I have placed my Thevenin voltage value to Thevenin and my Thevenin value next to this resistor. Depending on the problem, they might only want what's in this orange box, or they might want you to connect it back to the R load. Now that we simplified the circuit, we can change our load and solve this circuit multiple times without going through the entire process. I can make my R load to be 4 kilo ohms, I can make it to be 8 kilo ohms, and I'll have a much easier process instead of starting with the original circuit. We can also explore different power matching applications. Thank you for watching.